Hello, physicists. Sorry I can't be there today, and also sorry for the poor quality of the sound in this video. But I just wanted to give you guys a little bit of heads up on how to run the lab that we're going to do today. So we are going to get into our Stinky Feet lab. And before we do, I want you just to remember the graph that we were looking at last time. I call this the two-phase behavior of friction because if we remember, we saw kind of two distinct regions in our friction graph. At the beginning here, we see that the applied force and the frictional force kind of grow together. And that's kind of the region, if you recall, where our block of wood was sitting still, the static region. That's something we're going to look at another day, but for our Stinky Feet lab, we're going to focus our attention right on this region here. If you remember, that was the region where the shoe was, that's right, dragging along the surface with constant velocity. So that is the kinetic region right there. Okay, so friction has one set of rules in static conditions, not moving, and another set or a different type of behavior in kinetic. Okay. Side note, when we look at this, it's roughly constant right here, the frictional force, but it does bounce around a little bit. And so if we were trying to describe, what should we record for the frictional force in this, that the degree to which it bounces around kind of tells us what our margin of error should be. So earlier in the year we talked about rules of measure for analog and digital devices, where in this case it would probably be reasonable to think of the margin of error as kind of how much these bounce around. Remember that for what you're going to do with your lab. Okay, speaking of, we'll come back in the next, when I'm back in class, and talk about a little bit more about the nitty-gritty of how friction works and what cold welding is. But for your lab work today, the purpose is going to be to study the force of kinetic friction between a shoe and its different surfaces, and then how can we kind of boil it down to a single number, that is the tackiness of a shoe/surface combination. How can we describe that as simple as possible? So there are lab guidelines, and you're going to find those on Google Classroom, but I do want to give you a little bit of nudge in the procedures on how to do this. And you guys are going to figure out the nitty-gritty of the procedures on your own, but I'm going to give you some basic guidelines to work with. Okay, you will be using a shoe, and you are going to use the force sensors just like we did last class. Kind of the technique is to hook that sensor onto a shoelace, and then you're going to drag it across your surface. And since we're only looking at kinetic friction, we need to make sure we drag it across the surface with constant velocity. Okay. And one other thing that we're going to look at is the effect of changing the normal force. Okay. How we're going to do that is capture some data with maybe our shoe just by itself, then add a little bit of weight, drag that shoe again, add a little bit more weight. You get the idea here. That allows us to manipulate the normal force, if you think about it. So everybody will start with their shoe on a wood plank, and then after that you're going to kind of choose a variety of surfaces of your choice. So it could be like the tabletop, it could be the tile floor in the physics room. You can kind of get creative with that. We'll have some random materials out, and if you think of anything that you would like to test, you can do that. But a couple things to be wary of. Well, first, remind ourselves of what the free body diagram of this shoe would look like and how that's going to allow us to get the information that you're going to need for this. So remember, we're going to have weight down. Since we're on a flat surface, we can reason that the normal force is equal to the weight. And as we drag this thing, we're going to have friction going in that direction, so we can reason that what we pull with, or what the force sensor is reading, is equal to the frictional force, as long as this thing's in dynamic equilibrium. Okay, so some fails that can happen with this technique, don't let it be you. If you're pulling the tension force at an angle, we're going to kind of get that whole problem that happened with the suitcase. the assumption that our normal force is going to be equal to gravitational force would be invalid. So that would be a fail. I don't know how this would even happen, but I have seen it happen in the past where if your surface isn't flat, we get some weird complications to that as well. And then if you're pulling so hard that your shoe doesn't slide with constant velocity, that it accelerates across the table, then these two things are going to be out of balance, and that would also be a fail. Okay? So for today, you're going to log into a computer, find the assignment on Google Classroom. While you're there, you're also going to access the LHS lab rubric. It'll be on the same assignment page. And you're going to dig into this lab handout and read the instructions. And there are quite a few, because this is kind of going to be our first formal lab write-up of the year. And after you kind of get a good feel of what the expectations are for this lab and what you need to do, you're going to begin to devise a method to collect data and capture some dummy data. Okay, so the go-getters in the class are going to want to start moving forward on this lab report right away, and I'm going to encourage you to really take the time to think about what data you're going to collect, how much is enough, and just the technique to get usable data, so that you're not struggling on the back end of this lab report with data that's not really helpful. Okay. One other thing that's a little bit of a complication to this lab is that we're kind of manipulating two independent variables at once, and that's okay, as long as we only manipulate one at a time. Okay. So can you see what our independent variables would be? You're all screaming at the top of your lungs right now. The surfaces and the normal force, right? Okay. So if I go to my wood plank here and I do a trial with an empty shoe and then a trial with all these varying different masses, that's okay. I can do that because I'm holding the wood plank constant for that set of trials while I manipulate the weight and or the normal force. Okay. Then it's kind of like almost a separate experiment. When I come to a new surface, I can go through that process again of changing the weight, and that's a valid way to do this and get data that happens. And what it's going to mean is we're going to have several separate data tables, and the lab instructions kind of tell you how to manage that. But we're going to end up making a new graph for every surface combination that we do. All right, so that's a lot to digest. I really encourage you to read the lab instructions, and hey, good luck to you guys. Try to be flexible, get a good start on this, and I'll be back next class. Bye, guys.